Okay. Okay, so inclination angle is a positive angle theta measured counterclockwise from the x-axis to the line. Okay, so we're going to talk about graphing lines, and we're going to talk about slope. So when you see M, that stands for slope, just like in algebra. Okay, theta is going to stand for the angle. So if you were looking at graphing lines, that's like my x-axis, my y-axis. Let's say this is your line. Okay, this right here is the angle. That's with a positive slope. Okay, or you could have a line that has negative slope. And this is your angle. Okay? Counterclockwise, positive. Now, what do you notice about both of these angles? What quadrants are they in? 1 and 2. Does the line go into quadrants 3 and 4? Yeah. Yes, but we're just going to focus on where they are in 1 and 2, because if you find that angle, it's going to be the same line. It's going to capture exactly the same. Okay, and when you're dealing with slope and angles, you're going to be dealing with the tangent. Okay, if you remember, tangent is equal to y over x. Okay, and I gave you some shortcuts on the tangents. Like at 30 degrees and pi over 6, the tangent was square root of 3 over 3. At 45 degrees, or pi over 4, the tangent was 1. And then at 60 degrees, pi over 3, the tangent was square root of 3. Okay, that works for every quadrant. It just changes, like in quadrant 2, the tangent is negative. Quadrant 3, it's positive. Quadrant 4, it's negative. Okay, not all of these angles and all the slopes are going to be perfectly on your unit circle. So if it's not, we're going to use our calculators and we're going to round. Okay? So this will be the formula for slope. If you're just given either slope or the angle, we'll go back and forth. And then if you have two lines and you have to find the angle, this will be our formula. So M2 would stand for the slope of line 2. Excuse me. M1 would stand for the slope of line 1. What did the big bar stand for? That's right. So we can say positive before we do our tangent. Okay?
I thought it was MT.
I know my handwriting's not that good, but find the slope of the line with inclination theta. We good now? Okay, so the formula for slope is the slope equals tangent of the angle. So I know my slope is going to equal the tangent of pi over 6. Okay, pi over 6 is on your unit circle. So what's the tangent of pi over 6? Square root over 3. So that means that is the slope of this line with that angle.
This is probably a stupid question, but why wouldn't it be square root of 3 over 2?
Because that's when you're looking at these points, that's your point, but tangent's y divided by x. So then what happens is you get 1 over square root of 3, and then you have to rationalize it.
Got it.
Okay? So if you're finding like the cosine, it would be square root of 3 over 2.
Okay.
Okay? Okay, what about pi over 3? So my slope would be the tangent of that. What's the tangent of pi over 3? Square root of 3. Okay, so these were both, excuse me, both of these were on your unit circle. So you need to have the perfect answers. Okay, we'll do one that's not. Okay, 1.27 radians is not perfectly on your unit circle. Okay? So if I want to find the slope, I'm still going to do tangent of my angle. Okay, but this isn't going to come out perfectly, so you're going to have to use your calculator. Now, my calculator is set up in degrees, so before I can plug this in, I have to change my calculator to radians, because the angle that they're giving you is radians.
How do you do
You are
that?
a rat.
DRG. Very top next to second. Okay. And then go over to RAD for rad. And then just do tangent 1.27. Do you hit enter on rad? Yeah.
3.2.
Okay, so I'm going to be consistent with the book. Besides degrees, everything else they do is 4 decimal places. Degrees, I think they do 1 or 2, but everything else is 4, so let's be consistent with the book. Unless it tells you specifically what to round to.
Wait, how did you get that?
Tangent of 1.27.
Okay. So you just plug that in.
Just make sure your calculator's in radians because your angle's in radians. Everybody okay with finding the slope? Okay. No, go the other direction. Okay, so this time we're trying to find the angle. And we're going to find it basically have 2 answers. It says find it in radians and degrees. Okay? We're using the same formula. The only time you use the second one is if you're given 2 lines. Okay? So I have my slope. So -1 equal to tangent theta. Okay, so this one is on your unit circle, whether it is or isn't. You can always do tangent inverse of this number will give you your angle. Okay, now it will not give you the perfect radians. So it's not going to give you like pi over 3, okay? But it will give you, if it's in degrees, what your answer is in degrees. Okay, a couple things. You're looking for a positive angle. We have to have it in degrees and radians. Okay, where would this be in quadrant 1 or quadrant 2 if my slope was negative?
2.
Quadrant 2. Okay, does anybody know what it is without using their calculator? 45, which is 3 pi over 4. Okay, if 45 is 1, then negative 1 is the 45 degrees over here, which is 135. If you do it on your calculator, calculator should be in degrees. So you just change it to radians, now you gotta change it back to degrees. And you do tan inverse of negative 1, you would get negative 45. So how did I get 135 out of that? You add 180. Okay, so if you don't know your unit circle, you can use your calculator to help you out. You're just not going to have negative angles. Do you remember how to convert to radians if you don't remember what it is? Like if you don't know those two match up together? Okay, if you don't know, you can multiply by pi over 180. It's one of the very first things we learned this semester.
We already learned.
That's for a unit circle.
And then it reduced to that.
No, it's not.
So we talked about this back in 4-1. Okay. You want to go all the way back to first semester, or beginning of this semester?
For the first set of directions, is there a way for you to put it in your calculator and it give you like square root of over 3 or square root of 3 instead of other decimals?
Not on my calculator. Are there calculators that do it? Yes.
Are we allowed to use them?
Not on your final exam, but on the test, yeah. Your final exam is the only one that has rules about calculators. I don't have. I'm trying to see if anyone in here has a calculator that does that.
Probably not.
No.
I'm gonna go out and buy one. I'm gonna research it and buy one.
There are though, some that do.
I'm just gonna buy
Okay.
it and grab it.
Alright, let's do one that's not on your unit circle. 3/4.
Really?
Are you sure?
Okay. What quadrant would this one be in? Positive slopes. 1. Okay? We're not even going to talk about quadrants 3 and 4, so you can kind of just forget about them. Okay, we're going to focus just on 1 and 2. Alright, so 3/4 is not on your unit circle, so if I set this up, 3/4 equals tangent theta. So to find the angle, we're going to do tan inverse of 3/4. You want to do degrees first or radians first?
Degrees.
Okay, so my calculator's in degrees. If I do tan inverse of 3/4, okay, we'll go 2 decimal places on degrees, 4 on radians. So 36.87 degrees, did you guys get that?
Yeah.
Okay. So then if I go do radians, and I find the same answer. Okay, so if you just change your calculated radians, and you hit enter again, you don't have to like replug in the whole problem. .6435.
So is there not like a symbol for radians?
You can put the word radians if you want, but no. It's assumed. That's why you do the degree symbol for degrees. Everything else is assumed to be in radians.
Okay.
Okay?
We should make a symbol for radians, like a weird R.
And if you want to create one,
I'm down.
No, no. I don't know. Huh? What's in this one? I don't even know the ones we got last year.
okay, let's do one more.
I got one.
Is it a different set of directions?
Nope, same set of directions.
Like a dark gray.
Like how many lines?
I don't
It's
know.
the same emblem. It's like
They just made it very small.
it's the president, like the what's it called? The four president people. Yeah, it has not like on it.
I mean, you're gonna have more problems tomorrow with the same set of directions. So if you're about going to another page, might as well.
You don't know about it's not my friend.
Okay,
Take parts.
I'm still not using this other equation because we're still just doing one line. Okay, but I'm not given slope directly. So what do you have to do to find slope?
Oh, you have to put
Put
it in
it-
slope form.
Okay, put in slope intercept form, which means you're gonna solve for y.
Why is it?
Okay, so your goal is you wanna put it in slope intercept form so we can find what the slope is. Okay, so if I move the 6x and I move the 8 over, or you could move the 2y to the other side. Negative 2y equals negative 6x minus 8. Then I would divide everything by negative 2. So I have y equals 3x plus 4. What's my slope?
3.
3/1.
Okay, now it's just like 4 and 5. Okay, so I'm not getting 2 lines, this is still just one line. So then I would have 3 equals tangent theta. 3 is not one of your perfect ones. So you're going to use your calculator and you're going to find tan inverse of it.
Is this supposed to be in degrees or radians?
You gotta do both.
I think I got it.
And I know some of you aren't doing this. I hope you know how to convert your calculator. That's why I encourage you to do it. Okay.
Then you can switch it.
I didn't do that right then.
Okay, so you get 71.57 degrees, and then 1.2490 radians.
Does it matter which one comes first?
Nope. I'll know the difference because degrees will have the degree symbol. If you want to put the word radian or RAD after it.
I'm gonna come up with
Is there a
weird
big
some
difference?
letter R.